Hello, welcome to demola, and today's lesson we are going to be talking about group 2 on our periodic table. Magnesium, calcium, strontium, the whole lot. Going to go through its properties, reactions, the must-know for your A-level chemistry exam. Let's get straight into it. Okay, so group 2 metals. We should be able to find them on the periodic table. So, go from the left, second group that you see, the second vertical column is group 2. From beryllium all the way down to radium. Yep. That is your group 2 metals. And we just need to know some facts. All of them, giant metallic lattices, giant repeating, metallic bonds, lattice regular arrangement. Forming 2 plus ions, so you can see that again, underlined in the blue, magnesium 2 plus, calcium 2 plus, yeah? And just make sure, let me just be good. If you are doing your equations, make sure that you write 2 minus, yeah? Ionic equation. Cool. Now, you also need to be confident with drawing the electron configuration. So all of them are going to end up with the highest energy occupant being an s orbital. On s subshell, that's going to be fully filled, s2. So for example, magnesium, because in period 3, 3s2. Calcium, because it's period 4, 4s2. Strontium, because period 5, 5s2. Yeah? Just be confident with that. And then when they form their ions, they're going to lose those 2 electrons. So you see that those 2 electrons here, we'll draw them in red. These electrons get lost, right? So then, as an ion, the electron configuration, the highest occupant is going to be P, so 2p6. Hope that makes sense in terms of a basic understanding of the group 2 metals. Our next focus of our exams is going to be reactions. So, unfortunately, no easy way to remember this. You just need to know what's formed, yeah? So, when they react with oxygen, they're going to form a metal oxide, and that's it. State symbol is pivotal. It's pivotal. Group 2 metal is solid. Oxygen is a gas. Metal oxides are solid. Yeah. And then in terms of the balancing, I wouldn't stress about memorizing that. I think it's something that you'll just be able to do in the exam. When we add with water, we're going to get a metal hydroxide and hydrogen. Yeah. Now, what I needed to highlight is knowing your hydroxide is OH minus. So because it's 1 minus, you need 2 of them for every single mole of the group 2 metal. So that's why you'll get this sort of equation that I've underlined there. Now, you need to know the metal is solid, water is a liquid, the metal hydroxide is aqueous, and hydrogen gas is gaseous. Now, metal hydroxides become more soluble going down the group, and we need to be able to explain why. This is commonly missed in exams, right? As you go down the group, we're going to have more electron shells, right? So your metal cation is going to be larger or have a greater atomic radius. That means that the attraction between the outer shell and the nucleus is weaker, right? But also, the attraction between that metal cation's nucleus and the metal hydroxide is going to be weaker, right? That means we need less energy to break bonds, which means our lattice enthalpy is lower. You'll learn that in topic 5. But our lattice enthalpy is going to be lower, meaning that we can dissolve these metal hydroxides more easily as we go down the group. When you react with a dilute acid, you're going to form salt and hydrogen. And remember states, so like we said, metal is solid, the acid is going to be aqueous, the salt is also going to be aqueous, and hydrogen is gas. Now, only thing I need to point out, just know if you're working with like a 2 plus, a 3 plus, 2 minus, 3 minus, or minus ion, yeah? It's like for hydrochloric acid, Cl minus, right? For carbonic acid, it's CO3, 2 minus. Okay, something really important that we cannot forget is trends, right? So, ionization energy is the first one we need to talk about, and it's actually going to decrease down the group. Again, we've talked about this in a previous lesson, but we are just going to recap it. If we have more shells, we have more shielding, right? More shielding means the attraction between the outermost electrons and the nucleus is weaker. So the electrostatic attraction, weaker, less energy is required to remove that electron. So ionization energy is going to decrease going down the group. Now, thankfully, our reason is exactly the same to explain why the reactivity increases. Literally the exact same reasoning. The only thing that's now different is if we lose our electron to form the 2 plus, so we've lost the 2 electrons forming the 2 plus ion, that means we're more ready to react with anions. Yeah, and because we're more ready to react with anions, that means that our reactivity goes up. And you can kind of see it in this diagram here. If we have more shells, you see that distance between the nucleus and the outermost electron is greater. As in, the distance here is greater than the, or is smaller on that side on the left than the one on the right. So that means that we're going to have a harder time drawing that electron. Okay, so it's question time. So we've got a 3-part question to start off with. Comparing magnesium, strontium. We're getting a reaction with oxygen reaction with dilute acid, and then a comparison. And then you're going to also explain the trend of reactivity in group 2. Showing you all the questions there. Have a good go. The bottom one is... Okay, so questions now. This one didn't ask for state symbols, which I says ignore. You can put it in, you can't put it in. Just make sure when they ask state symbols, you do. And again, we talked about the metal plus oxygen gets a metal oxide, and that's that. Balance it by yourself. Now, this is kind of a point I want to make. Whenever you produce gas, so as in we've reacted the metal with the acid, right? Hydrogen gas is produced, right? But make sure how are you going to see hydrogen gas getting produced? You're seeing a gas, sure. You're not seeing hydrogen gas. I don't even like the fact that this is on the mark scheme, so I'm going to cross it out. What I want you to say is that you're seeing bubbling, you're seeing effervescence, you're seeing fizzing. This is what I want you to say. You can also say that magnesium disappears. Yeah, the solid is no longer there, so we don't have a solid on the right hand side because it's gone. Yeah, that meant that the magnesium disappeared. Any of those answers, completely fine, but please just don't say hydrogen produced. You cannot see hydrogen being produced. All right. You also can't see a temperature change. That's why they're going to ignore that. Yeah. Okay. Strontium, more reactive. We've talked about this. We're going to talk about it again in the next question. Right? If it is more reactive, its reaction is going to be quicker. It's going to be more vigorous. It's going to get hotter because it's an exothermic reaction. Right? Think about those things. If it's more reactive, 10, most one I would go for. Okay, now the A-star tip. So, first one seems really basic, but just to know where these guys are, yeah? You don't want to be in the exam and be getting confused. You shouldn't, anyways, but just make sure. And then I think maybe the more important thing is about being able to state and explain trends, yeah? It's all good you telling me the reactivity is increasing down the group. I need to know why. So make sure you're really confident in explaining that trend. Memorizing the reactions of group 2 metals with oxygen, water, and dilute acids. Again, apologies. In the exam, I think they're just going to expect you to know this. They aren't going to give you the equation sometimes. Sometimes they will, sometimes they won't. But they do expect you to know the products of the reaction and how to balance things. In terms of what not to do, I couldn't think of much, but definitely, I think a lot of people go through the A-level not being able to explain that solubility trend with the metal hydroxides. So make sure that you can do that, because a lot of people kind of skip that out. I think I maybe mentioned it once I was talking now. Okay, so I really hope this video has been helpful, right? Any questions at all, drop them in the comments below. If you found the video helpful, please subscribe to the channel, like the video. We are very much on the road to 500 subscribers. I think we are about 4 or 5 away, which is fantastic. Would be a massive milestone. We've also got the TikTok and the Instagram, both at A Star Demola. Link should pop up